In this session, let us try to understand synchronous motor at loaded conditions, kind of armature reaction. At the end of this session, you will understand about reactive power altogether in a different way. Like, from flux point of view, you are going to get it. Okay, and then after that, once we start alternator generator, once it is connected with infinite bus, once it is grid connected, how to analyze inside the machine what's happening, you will understand. Okay, see, let us think of as a single phase transformer only, because our target is to derive conclusions and we should be able to draw phasor diagrams. And this is connected with infinite bus like transformer primary, because transformer primary will behave like a motor and synchronous motor is anyway motor. Okay, so this is connected with infinite bus and this is rotor. On this rotor, let me connect battery. Okay, in this section, I cannot be able to tell you how torque is getting produced. Okay, because it is just a transformer, no? So torque related how it is getting produced and all I cannot show you. In the detailed armature reaction, we will discuss that. Except that, whatever the conclusions we are going to get here, same conclusions will be valid. Okay, see, for example, means if field current is flowing like this. Okay, if field current is flowing like this, it's going to behave like N pole, and it will behave like a S pole. And for example, it is rotated. Okay, it is being rotated at synchronous speed. Okay, means as I told you, how that particular torque is getting produced and how it is rotating, we will discuss in detail. As of now, it's not required. Okay, because our target is conclusions. Our target is how to draw the phasor diagram. Let us simplify it. Okay, now for example, if this is 0, if this is open circuit, okay, for example, if this is 100 volts, okay, so back EMF should be 100 volts, no, even. Okay, and if for example, if one flux line is producing 1 volt, okay, basically number of flux linkages should happen per turn in a conductor, per turn. In order to produce 1 volt, roughly 10 to the power of 8 flux lines has to be linked. Okay, but anyway, forget about that. Let us take the scaling factor such that one flux line is giving 1 volt, for example. How many flux lines will be produced here? 100 flux lines. 100 flux lines. Okay, for example, is this AC or not? Yes, it is AC. Okay, so it should be AC. Okay, if it is AC, flux is going to be 0, positive max, 0, negative max, 0, positive max. Like that, this flux is going to be varying like this. Now, for example, it is aligned and being rotated in such a way that whenever this flux is maximum in this direction, for example, it is aligned here. Okay, for example, whenever this flux is 0, it is aligned here. Whenever this flux is negative maximum, N is aligned here, such that flux, if it is closed, okay, flux created by this and the flux produced by this are going to be exactly intact, in line. Okay, so let me repeat again. When flux is 0, let me keep it here. When flux is maximum, let me keep it here, such that when this flux is maximum, N pole, so flux is going to be aided. When flux is 0, let it keep N pole here, and flux is negative maximum, let us keep N pole here, such that this flux will aid this flux. Okay, so let us assume that it is being rotated that way. Okay, now for example, if it is field current is 0 open circuit, under that conditions what will happen? 100 volts, 100 flux lines. Okay, so means in order to produce 100 flux lines, it is not giving any flux, so 100 flux lines has to be produced by this only. So current will be armature current or no load current, whatever it may be. Let us think of I naught, some current. Okay, I forget about it. I okay, that's enough. Okay. Now for example, if I close this, then what will happen? My what do you say, field voltage, I'm increasing gradually. Okay. For example, 100 volt, 100 flux lines. Out of 100 flux lines, maybe I increased this such that field current is getting increased. Because of that, like flux produced by this is 20 flux lines now. 20 flux lines. Okay. So here 100 flux lines are required. 20 flux lines are created by this. So how many more flux lines has to be created by this? 80 only, because 100 volt, 100 flux lines. So in order to create 80 flux lines by this winding, my current will be reduced. Now, if field current is again increased such that this particular field flux is 50 flux lines. Now, if it is producing 50 flux lines, how many flux lines more it has to be created by this 50? So, only 50. Now, compared to 100, it became 80, now became 50. So, current is going to be reduced. For example, if it is producing exactly 100 flux lines, okay, if it is producing exactly 100 flux lines, how many more flux lines has to be created by this? 0. Okay, under that conditions, how much will be this current? 0. Now, for example, if 120 flux lines are created by this, okay, it is also rotating, and this flux are exactly aligned. Okay, so if 120 flux lines are created by this, here in this case 100 volt, 100 flux lines. So if it is creating 20 flux lines more, that particular flux lines has to be killed by taking some amount of current here. Getting my point, right? So if it is producing 150 flux lines, extra 50 flux lines should be killed by this. So in that way, current will be taken. Okay. Now one thing. Okay. See here, this is infinite source. Okay. In power systems, they will consider like voltage variations, frequency variations. It means like in power systems we'll see, but from machine's point of view, this is infinite source. Infinite source in the sense, amplitude of voltage and frequency cannot be changed. Whatever the current you want to take it. Whatever the current you want to give it. Whatever the active power or reactive power you want to take it. For active power, pay for it. If you want to, for example, sell power to the infinite bus, you please sell it, take the money. Okay, so we should not question like for example, if I say reactive power is being supplied by this, you should not ask me where that reactive power is going to be utilized. Should not be thought, because it's infinite bus. Somewhere it will use that particular reactive power. Okay, for example, as of now I'm in a room. If I switch on my fan, now my concern is whether my fan is rotating or not. Should I bother about from which generating station, of which state? Okay, so I'm going to take that power. Do I bother about it? No. Okay, similarly infinite bus means that any amount of active or reactive power you please take it, or any amount of active or reactive power you please supply it, it will absorb. That's it. If you supply, it will absorb. If you want to take, it will give. But you should not question that from where that active power came, from where that reactive power came, or like if I supply reactive power, where that reactive power is going to be utilized. It's none of our business in machines. Okay, now coming to the point, for example, when this is open, okay, so it's kind of transformer only. When this is open, this is a transformer only from this side, because current is not there, 0, flux is not there. So let us draw transformer primary side phasor diagram. 100 flux lines, and means motor in the sense this side generator, this side motor. So this is going to be minus E1 equal to V1. Okay, how my current is going to be more or not? Yes. So in transformer we considered no load current is like this because of hysteresis and eddy current, but that non-linearity need not be bothered now, because that non-linearity and double valued BH loop and all already we discussed in transformer. So directly I will consider I here. Okay, now if I increase this particular field current, flux created by this increased to 20, so how many more flux lines has to be created by this? 80, so it reduced. Length of the phasor is reduced. For example, it is producing 50, extra 50 has to be produced by this. For example, it is producing 100 flux lines, means it need not produce any flux, 0. For example, if it is producing 120 flux lines, extra 20 flux lines has to be killed or not? Yes. So that extra 20 flux lines has to be killed means that it will start taking current in opposite direction. Okay. If for example, if it is producing 180 flux lines, 80 flux lines has to be killed. Okay. Now let us try to draw with respect to field current my current of the stator. If field current is zero, total flux line should be created by this only. As of now, under no load conditions only I am discussing. Okay, so this particular flux created by this is 0, so 100 flux line should be created by this, so current will be maximum. After that, if I keep on increase field current, my stator current is going to be reduced to 0. So now in this case 100 flux lines are created by field only. For example, if I still increase the field current such that it is producing 20 flux lines, 120 flux lines, extra 20 flux lines has to be killed by this. So again my current will increase in leading direction. Now forget about all. Actually this is V curve only. Okay, so in V and inverted V curve already we derived. Okay, anyway, forget about it. Now coming to the point. See, for example, if any load is there. Now for example, here resistance is there and reactive element is also there. So for example, if this reactive element is inductive, if it is inductive component of current should be lagging by voltage. So lagging or not. Okay, here if it is absorbing reactive power, in this case it should absorb reactive power or not, because with respect to voltage minus E1 equal to V1. Okay, so with respect to voltage current is lagging behind. So this is going to be motor only or not? Yes. Motor is going to absorb power or not? Yes. Okay, so from motor point of view, if motor is operating at lagging power factor, it has to absorb reactive power. If motor is operating at leading power factor, it will deliver reactive power. That's it. Okay, so from here to here, it is operating at lagging. So motor is absorbing Q, reactive power, and from here to here, it is going to deliver Q. Because it is operating at leading. Okay, now one thing let me tell you, when my motor is going to absorb reactive power, if it is operating at lagging, when motor is going to deliver reactive power, when it is operating at leading, that's clear. Okay, now come back to here. Okay, when it is taking reactive power in order to set up the flux, because for example if it is producing 50 flux lines, extra 50 flux lines has to be set up by this, so it is taking lagging reactive power. Okay, so my motor is absorbing reactive power to set up the flux. How is it? Okay, now for example, if it is producing 120 flux lines, extra 20 flux lines has to be killed by this. So it is my current is going to be leading, it is going to supply reactive power. So if we see reactive power as of now, we can say that motor to set up the flux, it will take the reactive power. To kill the flux, it will operate at leading conditions such that motor will deliver reactive power. Getting my point, right? So means reactive power previously we discussed in a different way, but now to set up the flux, reactive power will be taken. To kill the flux, reactive power will be supplied back. Okay, now see, for example, many times people ask me, sir, in motor, synchronous motor, okay, in synchronous motor, how it is able to deliver reactive power. For example, if I over excite this, okay, if I over excite this means that I am going to supply field current such that it is delivering 120 flux lines. So I over excited. If I over excite, then what will happen? Extra 20 flux lines has to be killed by this. So it will deliver reactive power. If it is under excited, means that it is delivering 50 flux lines only. Remaining 50 flux lines has to be produced by this, so it will absorb reactive power. So under excited, absorb reactive power, over excited, deliver reactive power, So from voltage point of view, okay, so from voltage point of view, for example, this is voltage. Okay, now for example, my motor is there, my motor is delivering active power is only real power. Okay, so motor output is only active power, it is not reactive power, because reactive power is not a power, no. Okay, so for example, my motor is pumping my water. Okay, so my motor is pumping my water. In order to pump my water, which is required, active power is required. Then people feel like, say, sir, like, if motor is absorbing reactive power, where it will go? Because it is absorbing reactive power, but it is not a power, no, nowhere it will go. Okay, and if motor is delivering reactive power, from where it will absorb? It need not absorb from anywhere, because it is not a power, no. Why we are bothering about reactive power? By considering transmission line and load end. In load end, if reactive power has to be supplied, my magnitude of current in the transmission line is going to be increased, transmission loss and all we discussed. Okay, now for example, if I say my motor is delivering 100 kilowatts of power. Okay, so my motor output should be always active power, actual power. Okay, for example, this is my motor power. This is my motor power. Okay, so VI cos pi is anyway unity. Okay, power factor is unity. Under that condition, V into I is going to be 100 kilowatt, for example. Now, in this motor, if I supply field which is less than required, then my stator has to operate at lagging conditions such that it has to absorb reactive power. So this is going to be I of motor. Okay, if I of motor in this way, okay, what is active power is same, Vi cos pi is same, so it is delivering same active power, it is working same. Okay, but as field flux required is you did not produce, so extra flux lines has to be set up by the source, so it is absorbing reactive power. Okay, so if my current is lagging behind, what does it mean? Over excited or under excited? Under excited. Okay, now for example, if I set up here flux more than required, under that conditions my current can be like this. Okay, such that again Vi cos pi is going to be same, but it has to take some current, it has to take some component of current. See here, it has to take some component of current to kill the flux. So IP is going to be same, in phase component of current is going to be same, but reactive power component vary. Okay, for example, if you are producing by your field current exactly the flux lines required is going to be Vi, but output power will be same, actual power. Now for example, if you are unable to produce the field required, flux required in the air gap by through your field winding, my source will take care of it, and my source will take the reactive power by operating at lagging power factor. Okay, so at lagging power factor, see here in the phasor diagram, only for reactive power component I have shown here. For lagging, it will set up the flux. For leading, it will kill the flux. So if you are unable to produce the flux required by your field winding, this component of flux will be automatically created by the source, such that it will operate at lagging. For example, by your field, because this is going to field is going to be separate. Okay, so by your field, if you are able to produce more flux than required, under that condition my stator, my infinite source will automatically give some current in order to kill the extra flux. That component is this. Okay, so in these three cases, IM and this, in these three cases active power will be same. Okay, so in this way we have to analyze. Even alternator also, once it is connected with infinite bus. Now once it is connected with infinite bus, grid connected means almost same. Okay, so see here, once alternator is connected with infinite bus. Okay, under that conditions again same scenario, if you are able to produce field flux which is exactly required, then alternator will operate at unity power factor. If you are producing more flux than required, then it will take component of current to kill the flux. Over excited. Okay, and if you are producing an alternator less flux than required, then automatically from the source it will take component of current to set up the flux, under excited. Okay, let me draw two phasors. Okay, actually in this few guys may get one doubt, but that particular doubt I will take care automatically in the original phasor diagram along with the original armature reaction. Okay, now see here, for example, this is flux. Actually I am doing a small mistake, but it's okay, because we will see, we will take care of it at later point of time. This is going to be voltage E. Okay, motor or generator? Motor. Generator, motor. In motor, for example, if it is operating at lagging. Okay, so where is pi r will be in line? Where is pi r? Okay, actually result should not increase, like I will take care of it later. Okay, so and second thing is, for example, operating flux E, if my current is leading with respect to E, it is leading, so this is going to be pi r, In this case, magnetizing or demagnetizing armature reaction effects at no load pi, because of the load it is being aided, so this is going to be magnetizing armature reaction effects. Okay, and is it supplying reactive power absorbing source? Oh no, it's load, motor, load. So motor is operating at lagging, load is operating at lagging. For example, an alternator, that is load. When load is operating at lagging, it is absorbing reactive power. So it is absorbing reactive power. Okay, now you have to you made this under excited or over excited. It is taking some component of current to set up the flux. Means that you did not give field flux required or flux required in the air gap through your field winding, so it is under excited. Okay, now if you think of here my motor is operating at leading. For example, I am the generator, that is a load. Now that load is having dominating capacitance effects. Okay, so the moment load is having dominating capacitance effect, then only current will be leading. If it is having dominating capacitance effects, capacitor is a supply of reactive power, that is the notation we have been using, that is supplying. Who has to absorb? I have to absorb. Okay, so motor which is operating at leading power factor, absorb or deliver reactive power, deliver Q. Okay, over excited or under excited, actually some component of current is leading. Means that your field flux required will be there, and through your field winding you produce field flux more than required. That's why it is taking some component of current to kill the flux. Over excited. Magnetizing or demagnetizing armature reaction effects? Demagnetizing. Okay, now at the end, forget about all. We need not remember. Okay, for example, see, this is the operating flux, pi naught. Okay, focus here please. This is the operating flux, pi. And if I consider E this way, okay, if I consider E this way, means that it is motor. If I consider E this way, means that it is generator. Okay, so this is flux, this is generator, induced voltage E. So with respect to generator, if I think of with respect to this IA lagging means that pi A will be here, pi F is here, pi A is here. Demagnetizing or magnetizing? Demagnetizing. Okay, so pi F, pi A is going to pi R. Okay, so alternator operating at lagging power factor, having demagnetizing, because IA is here, demagnetizing armature reaction effects. Okay, so demagnetizing armature reaction effects means that my field flux has to be increased, over excited. Okay, so in alternator, for example, I am the alternator, that is a load. Okay, so why I should operate at lagging? Because that load is operating at lagging. When load is operating at lagging, that particular load has to absorb reactive power. Who has to supply? I am supplying reactive power. So alternator operating at lagging, supply reactive power. Supply reactive power. Alternator operating at lagging, supply reactive power. How? Demagnetizing armature reaction effects, because pi A is here. Demagnetizing armature reaction effects. Right? So demagnetizing armature reaction effects, supply reactive power, alternator operating at lagging power factor, overexcited. Because it is having demagnetization, no? So we have to overexcite. Now, for example, pi, alternator, V, okay? So E. Now pi, alternator induced voltage is here. With respect to this, IA is leading. Okay? If IA is leading, pi A is here. Pi A, pi F, pi A. Now pi R is going to be more. Okay? So alternator operating at leading have magnetization armature reaction effects, because net flux is getting increased. Now, for example, I am an alternator. Load is connected. I am operating at leading power factor. Why should I operate at leading power factor? Because load connected is capacitive dominated. Okay? So capacitance will deliver reactive power. So I have to absorb reactive power. Now, let us combine all these. Pi, generator, leading, pi A, pi F plus pi A is increasing. So generator operating at leading have magnetization armature reaction effects. So field current should be reduced, underexcited, absorb reactive power. Now let us think of motor. In motor, pi will be here and E will be here. Okay, so E is here. With respect to E, for example, IA is here lagging. If IA is here, leading. Okay, so pi A here, E here. With respect to E, IA is leading. If IA is leading, pi A will be here. Pi F is here, pi A is here. So demagnetizing. Okay, so means synchronous motor operating at leading power factor. Leading power factor have demagnetization armature reaction effects. Now, means will it supply or absorb reactive power? A motor, not alternator, it's a motor. Motor operating at leading. When load operated leading, when it is having capacitive dominating effects. So when it is operating in capacitive dominated way, automatically it has to supply reactive power. So, means altogether let us combine motor operating at leading have demagnetization armature reaction effects. So, should be overexcited. Okay. Now, it is having demagnetization armature reaction effects. Leading motor, supply reactive power. Okay. Now, let us think of motor, don't remember this. Just think of phasor diagram of transformer. Okay, for example, pi E, motor or generator motor, with respect to E, my IA is like this, lagging. So pi A, pi F, pi A plus pi F is going to be more. Okay, so motor operating at lagging. So I'm alternator, motor is there, motor is operating at lagging, means that it is having inductive dominated, means that it will absorb reactive power. Okay, so motor in the sense, there you have to say it. Okay, it is alternator, that is motor. So motor operating at lagging, absorb reactive power. This is going to be absorb reactive power and having magnetizing armature reaction effects. So it should be underexcited, because when in a motor lagging currents will be there, underexcited only, no? So underexcited motor absorb reactive power. Overexcited motor, it will take leading currents. Okay, so overexcited motor deliver reactive power. Okay, now generator motor, if I combine, okay, overexcited synchronous machine, alternator, okay, lagging, demagnetization, overexcited, motor leading, component of current is leading, means it is my source is driving the current to kill the flux. So overexcited. Okay, so overexcited motor, okay, or overexcited generator deliver reactive power. So overexcited synchronous machine deliver reactive power. If you think of underexcited, means generator This is generator under excited, generator operating at EF leading. Okay, so generator operating at leading have magnetization armature reaction effects, so it should be under excited. And for example, motor operating at lagging. So motor having lagging power factor have pi A, pi F. So magnetization armature reaction effects. So in a motor, when you are going to get lagging component of current, you are unable to set up the flux required by the air gap through field winding. So it will take extra component of current. So it will be absorbing reactive power. So altogether conclusion is very simple. Over excited synchronous machine synchronous machine deliver reactive power. Under excited synchronous machine absorb reactive power. Over excited alternator, for example, forget about all. Over excited synchronous machine supply reactive power. Okay, so when generator supply, for example, I'm the generator, when generator supply, when load is absorbing it. When load absorb, inductive. So I have to operate at lagging. So alternator operating at lagging will deliver reactive power. Overexcited, demagnetizing armature reaction effects. Okay, for example, as a motor, when it delivers, overexcited synchronous machine deliver reactive power. Overexcited synchronous machine in this, let us think of motor. When, for example, that is a motor, I'm the alternator, that is the motor. When motor deliver, it should have capacitance effects. When it will have, what is the power factor of the motor? Leading. So my motor operating at leading deliver, generator operating at lagging deliver, both should be overexcited. So both should have demagnetizing armature reaction effects. Okay, now let us think of underexcited synchronous machine absorb reactive power. Okay, when alternator absorb, my load should deliver. When load deliver, capacity effects, so it should operate at leading, I should operate at leading. When that load, capacity dominated load is connected to me, I have to operate at leading. So alternator operating at leading absorb reactive power because that capacity effect will deliver. Alternator operating at leading absorb. Motor, when motor absorb, you should have inductive dominated. Okay, so motor absorbing at lagging, generator operating at leading absorb reactive power. Both should be underexcited. Okay, so this is the conclusion. Again, I am going to repeat everything. Once I start the real armature reaction of the real synchronous machine, then once I repeat, if you are unable to understand, repeat the video multiple times, you will understand. Okay, again I am going to repeat this in original synchronous machine armature reaction.